Oh, hi there. Thanks for showing up for your teens learning. It's Grant, the SAT Genie. And today we're going to take a look at what I mean by how to use a peel the onion strategy to conquer some complex math questions. So let's take a look at this one. We've got a properly complex question over here where we have a very wonky expression. And by wonky, I mean we don't usually see this at the grocery store. One over one plus one over one over x plus two plus one over x plus three. Like, what do we do with that? Well, this might look like the stuff of math nightmares to some, because we don't tend to use this in the grocery store. So how are we to help our kids with it if we're not doing it regularly? For me, these are lovely little puzzles, and I really enjoy it when students are at the level to engage with this level of math, because it shows that they're able to put together a lot of different skills. And that actually, that bringing together of different skills is really the road by which we start our investigations into these types of problems. So the first thing that we want to ask a student is, what do you notice about this? Like, what looks familiar? And they might say, well, I see we've got algebra stuff, this x plus 2 and this x plus 3. I see we're adding together two fractions, and then we're dividing a fraction by a fraction. All right, if a student can tell you all those things, that shows a good awareness of what needs to happen in this problem. So let's go ahead and, I'm going to show you a shortcut with this problem in a minute, but let's go ahead and tackle this problem layer by layer first. So the first layer is adding or subtracting fractions. All right. Now, many of us will remember that if we're adding like 1/3 plus 1/4, we can't kind of add those things together. We don't have two of anything. We certainly don't have 2/7. That is very much not what this is. Um, so, what do we do when we got 1/3 plus a quarter? Well, first of all, we could think of like 1/3. If you remember, 1/3 is like 33% of something, and 1/4 is like 25%. And what I've basically done is I've converted the form of both of these numbers so that they're equivalent. They kind of speak to one another now. You can add percent to percent. This would work out to be approximately equal to something like 58%, something a little bit over half. Okay. And if we actually go ahead and dive in to look at Polypad here, Polypad's this really useful tool where if I've got a quarter plus a third, I can show a student who's maybe struggling with these ideas that that is going to be a little bit bigger than a quarter. How much bigger, I wonder? Well, this is what we need to do with this idea. We need to take this and we need to go rename it. So 1/4 could be 2/8. 1/4 could also be 3/12. All right. And I haven't changed the size of that 1/4. I just split the quarter into three pieces. And we're going to go ahead and split this third. It could be 2/6. It could be 3/9. Oh, it could be 4/12. Okay. Now we've got two things that we can add together. Okay. So just to look at that now, we can clearly see it's 7/12, which is, if I just grab like, one of these twelfths down here, just get another 12th out. Let me just go ahead and split them. Notice that like this one here, if I grab it, come on, there we go. If I put that one there, you see, that would be 1/2 and 1/12, or 7/12. So that's the difference there between, if we go ahead and unsplit that, that was our quarter, and that was our third. All right. Now, the students won't have access to Polypad during this test. They will have access to Desmos. There are ways to Desmos this question, but I'm not getting into that today. What a student wants, and so another thing is like, yeah, we got to a little bit bigger than a half there, and it was, that size. Why is my toolbar not going away? There it goes. Okay, so this is the algorithm by which we add these fractions. We need to be able to like wind this layer of the onion back for the students, because they may be missing this. So many students are struggling with fractions, and that's a lot of points on the SAT. Not just for these challenging questions. This challenging question I'm showing you is like a 780, 790 question. It's the high level math marks. But fractions and fraction operations and working with ratios and proportions, this is like 100 points. We really need this. So we saw that we needed to split this one into fours, and we needed to split this one into threes. What that does is when we do that, we ended up, this one here was 4/12, if you recall, and this one became 3/12. And together that gave us 7/12. And the reason we can add it together here is because now they're the same thing. They're the same in the denominator. So that's the principle that we're looking for. And we need to be able to peel this onion back like a skilled tutor when working with a student in a small group or one-on-one is usually I can most tutors will be able to notice the missing piece in their students' workflow, the one that's holding them back. A student, once they get this idea that the denominators need to be the same, 4 times 3 is the same thing as 4 times 3 here, it's 12 in both cases, we need to create that common denominator. Once the student has that concept, they need to be able to go practice. So that's where a tutor would also be giving you problems that you go ahead and practice so that you can get to this level of doing that very fluently. Okay, so let's go ahead and take this layer. We're going to bring this up here, and we're going to reapproach this question here. I'm just going to say that this is equal to, well, I'm not touching that top. It's going to say the same. 1 is 1 over 1 over x plus 2. I'm going to put that in brackets, plus 1 over x plus 3. I just rewrite so that I get it nice and tidy. And then I'm going to use this trick that I used over here. And I didn't really call the trick out, but notice this number down there, 4, I multiplied over here by 4. 3, I multiply over here by 3. I can do the same thing here. Here I've got x plus 2 on the bottom, but I have an x plus 3 on the bottom over here. So over here, if I multiply by x plus 3, and here by x plus 3, I do the same thing top and bottom to just split that into x plus 3 pieces. I don't know how many pieces x plus 3 is, but I do know that whatever x is, it's going to be 3 more than that. And then over here, I split it into x plus 2 pieces. It's exactly the same, but now it's being done with algebra bits, sort of like an alphabet soup of math problem. But it's exactly the same. Now we're going to go ahead and multiply those together. So I'm just going to refresh, get my blue pen back out. I'm going to say this is equal to 1 over, well, here I've got x plus 3 times 1. Something times 1 is just itself. So that's going to be x plus 3. And then we're going to add that to, oh wait, and that's going to be over x plus 3 times x plus 2. I'm just going to write that down as x plus 3 multiplied by x plus 2 for now. Okay, then we're going to add that here to x plus 2 times 1. Well, something times 1 is itself, so that's x plus 2. Okay, and I'm going to work horizontally here for a second because this question is going to spiral. There's a lot of levels. And here, I'm just going to collect these like terms. This is a very simple thing. We should have here layer 2 collect like terms and multiply binomials. So the next stage, the next layer of this is to resolve all the algebra bits. We've done this to the level that we can, and now we're going to go up a level, something a little more complicated. Of course, math is always building on itself, and a question like this brings together a lot of different ideas that need to be ready at a high level of fluency for students to score really well on this test. So when we look at collecting like terms, this is something, it's just as simple as this. Let's say I have one grocery bag, and I'm going to represent this grocery bag with these brackets. Inside that grocery bag are 5 apples, and for some reason I'm carrying money in the grocery bag, $3. And then I add that to another grocery bag with $5, but for some reason I also have another 2 apples in the other grocery bag. If I open both grocery bags up and add them together, I will have 5 apples plus 2 apples. That's 7 apples. And $3 plus $5, that's $8. This is what we mean. Put these together by addition or subtraction, whatever is being asked of you, and put these together. Same letter with the same thing, same number with the same number. Okay, this is what we mean by collect like terms. In case it's been a while since you've had to do those types of things, I gave you a grocery store answer, but we don't typically think about that at the grocery store. So I like that metaphor because it shows you why I can add apples together and I want to keep my dollars separate. Okay, I can't add the dollars to the apples. They're not the same thing. Similarly, these were not the same thing until I made them both 12ths. But that's a little different. Okay, so now I can apply that idea to this layer here. I have x plus x, so that's going to be 2x's, and plus 3 plus 2, that's going to be plus 5. And I'm noticing that that's looking like some of the things in some of these multiple choice answers. So I'm feeling like I'm on the right track. All right. And then we're going to divide that by, I don't see this in any of the answers, but I'm really suspicious that it might be something like that. So this is where we get to multiplying binomials. Okay, this idea here. This is another layer of the onion that I should have separated as a fourth layer. We'll need to know how to do that. This is again one of those skills that shows up frequently enough on the SAT that students need to know how to do this. Let's take a multiplication question, and we're going to do it the normal way and then a weird way. If I told you that I went to the store and I bought 12 dozen eggs, that'd be the same as saying 12 times 12. And you might ask, why do you like eggs so much? And I might ask, why are you avoiding the math question? And the answer to this question is, of course, 144. And students will know this. Teens will generally have their 12 times tables and they will know their squares. And this is a number that's very frequently on the SAT because it's so factor rich, like a dozen, full of factors. So they like this for their different questions. Anyway, I like to ask students this when they make the error I'm going to show you. And I say, oh, it's 144? I thought it was 104. Huh? Isn't it 104? Of course not. But because I say, well, I can write 10 as 10 plus, sorry, I can write 12 as 10 plus 2, and I can write the other 12 as 10 plus 2. So if I do 10 plus 2 times 10 plus 2, isn't that 10 times 10 and 2 times 2 to equal 100 plus 4? Of course it's not. It has to be 104 for this to be correct. And what we need to do in these cases is make sure everything in the first bracket shakes hands with everything in the second bracket, like they all get to multiply one another. So we'll often show it this way. The 10 will multiply the 10, and that will give us 100. The 10 will multiply the 2, and that will give us 20. This 2 will multiply the 10, that gives us a further 20, and this 2 multiplies by the 2, and that gives us the remaining 4. You see where the missing 40 was? It was in there with this handshake and this handshake here. Okay, so it's no different. Okay, we want to be able to peel the onion for our students and show them these examples that they already understand to show them the thing that they maybe don't understand. That's quite intuitive because we know we have a very quick error check that 12 times 12 is 144. But if I told you, well, what's up here? X plus 3 times x plus 2, let's zoom in on that. Get a little finer tip marker. Okay. And I said, well, I'm going to call that x squared plus 6. You see, I'm missing some handshakes. So I need to also have x times 2, which gives me plus 2x, and 3 times x, which gives me plus 3x. And now this section here, I'm back to gathering like terms. So let's, bring this down one more level. So this is going to be equal to, still that 1 is on the top. We haven't touched that yet. Over 2x plus 5 divided by this one here, x squared plus 5x plus 6. And now a student might say, well, it's like it's still an algebra soup. I may have gone through this process flawlessly to this point and still not know. I mean, I don't think it's that one. I don't think it's that one. I think it's some combination of the two, but I don't know if it's B or A. And I'd like a better than a 50% shot at getting these marks. I want the 100% shot at getting these marks. So what we do in this case depends on whether we can remember how to divide fractions. Let's say I have 2 chocolate bars, and I want to divide them into pieces that are 1/2 of a chocolate bar each. Okay, if I take 2 chocolate bars, and I crack each one into that many chocolate bars, that better give me 4, right? So that has to resolve to 4. Another way to think about that is, here is the piece of one chocolate bar. Here is a piece of another chocolate bar. And I am saying, how many half chocolate bars are in there? Well, there's 1, 2, 3, 4. That's 4 halves. So this is how we divide fractions. Like, this is the idea of divide fractions at an intuitive level. We can understand that. If I've got fractions that look like this, I'm beyond being able to use intuition to understand how to process that. So I need to be able to peel this onion back to stuff that I know. And I mean, students generally need help with this whole process to go back to things that they know. That's where having like parental support at home to be able to walk through this stuff, or having quality tutoring, can make a big difference. So anyway, now that we know that, well, how do we get there from this? And if we recall, that the thing that students will remember is keep, flip, change. I keep the top, I flip the bottom one to, so 1/2 flips and comes up here. Okay. And then it becomes, instead of a division question, a multiplication question. So we keep the numerator, flip the denominator, and change the question type to multiplication. And then this is just good old 2 times 2 is equal to 2. Okay. So this allows us to push this question across the finish line here. So we're going to keep the numerator. So this is going to be equal to 1 multiplied by this one flipped. So that's x squared plus 5x plus 6 all over 2x plus 5. We might as well put that all in brackets, because all getting multiplied by the 1, and something multiplied by the 1 is just itself. So this is just x squared plus 5x plus 6 all over 2x plus 5. That's it. Okay, and then we go in, we triumphantly find it. Wham, there. Great. Super duper. Now, that's really useful to be able to go through that whole process with your students, so that you can find out the things they don't know. This question here is worth 10 points on the SAT. Difference between a 790 and an 800, probably. Because if you're getting this question, you probably got the rest of the test. You probably full scored the math. These are hard. This question's not that hard, but this is not the hardest example of this. Okay. But if you're missing one of these layers can be way more points. So actually using these complex questions as a way to diagnose some learning gaps and then prescribe exercises that the student can do to close those learning gaps is really important. And I always like this idea of starting with things that I can use my intuition on, use these types of examples that we readily understand, and then be able to do these types of things that score points directly in an abstract context on the SAT. Now, I did promise you that I would give you a simpler way to answer this question. So how about we look at that now? Let me just get a fresh copy of it out. Excuse my desktop. There's Peel the Onion. Okay, so here's another test. This is called, this is a big secret actually. I usually only share this with my students. It's a test I created that quickly allows you to test 2 different expressions and see if they're the same. It's called the the 0, 1 test, okay? And we're going to let 0 or 1 equal x, because when, let's say, I'm just going to write out the equation again, 1 over 1 over 1 over, we've got plus there, we've got plus 2, we've got plus 3, and I'm just going to put some really colorful brackets here where x belongs, okay? Because what we're going to do is we're going to take turns making x 0 and x 1, okay? So here is the test when x equals 0. This expression is the same as 1 over 1 half, because 0 plus 2 is 2, plus 1 over 3. So when x is 0, this expression is equal to 1 over 1 half plus 1/3. 1 half plus 1/3 is the same thing as 5/6. So this is 1 over 5 over 6. And then we use our flip and multiply. That's equal to 6 over 5. Okay, so now what we want to do is find an expression that when x is 0, the value is 6 over 5. So let's check C. If this is x equals 0, then this would be 0. So that's 2 times 0, that's gone. This is 5. We can eliminate C. This one here, if x is 0, this is 0, this is 0, that's 6. So we've eliminated D. Okay, now we check this one. If x is 0, all that's 0, and that's 0. This is 6 over 5. Candidate, probably that one. If I check this one up here, this goes, that goes, that goes. This is 5 over 6 when x is 0. That's out. The answer is B. The answer is B because this has got to be it's got to be the same for all values of x. Don't worry about that. Ignore that. They just want to make sure that this does not equal 0 itself. We can't use x equals 3, so they just created some limitations. Okay, we can also use 1 here. 1 is also very easy. Sometimes you test 0. Very rarely you might find 2 of the expressions are the same for when x is 0. But honestly, I don't see them defeating the 0, 1 test that often, like defeating the first number. We haven't guaranteed that they're the same, but it's the only multiple choice that works, so it's the same. We can also test 1. So if I test 1, then it looks like this. I'm just not going to have 0 there. We're going to do this in green here. So that'll be 1. Oop. That'll be 1. That'll be 1. And this whole expression is equal to 1 over 3 plus 1 over 4. A third plus a quarter. We've already done that today. That's 1 over 7/12. And we'll find that this one here, B, okay, when we flip that one and multiply, 1 over 7/12 is 12 over 7, because remember, we're flipping this and then multiplying by 1, so it's just 12 over 7. We just flip the bottom. All right, look at this one. When x is 1, that's 1 squared plus 5 times 1 plus 6. So that's equal to 12 over, this bottom here is 2 times 1. It's over 7. Okay. Now, I've given you 2 ways to solve the question. One is, the second way is more of a, I'm going to cheat a little bit on the SAT to save a bit of time and to cut out a topic that I may not be 100% confident on. So that's a test taking strategy that we'd look at, say, 2 weeks out from the test for those areas where we have knowledge gaps. For my money, the real value of the SAT is where I dive in, seek to understand these challenging types of questions fully, and fully identify my knowledge gaps down below so that I can go into college and be super ready to have a fantastic experience there. So I hope what I've left you with after this presentation is just that idea that these types of math questions are actually a great opportunity to build up our skills for college and to consolidate all of our learning from high school. When we go through with that peel the onion approach, show me what you already know, student, son or daughter in your case. What does that look like in a simpler question? Can you explain how I would do it if it were just numbers and not algebra stuff? What about that algebra stuff? How do we deal with that? How do we multiply? How do we add and subtract? Where do we need to do some review? That can really show us some of those areas where we do need to focus a little bit more. And man, is that ever worth it, because you're going to build so much confidence going into that SAT once you close all those learning gaps and practice them. And you're going to feel that same confidence going into college, knowing you've done all of that work to get ready. So, again, I really thank you all for showing up for your learning. If you feel that you need some help identifying some of these learning gaps, I'm only a click away. My schedule is open to you, and I'm happy to meet one-on-one to see how we can help you maximize your score on the SAT. All right, all the best for your SAT success, everyone, and I do look forward to seeing you around the community. Bye for now. Oh, there it is.